How to set up a Keyestudio Relay shield with nodered on a Raspberry Pi. You may also be interested in our two companion videos, How to Use a Relay Shield and Relay Shield Electronic Workbench Testing Results. I bought my Relay Shield board in January 2018 from Amazon for $9, and I believe nothing about the hardware has changed since then. If anything important changes, I'll update this video. Here's what we're going to do in this video. First, we install the hardware. Next, the Pi's operating system. Then install the nodered software. And finally, the nodered driver. First, we look at the hardware. You could lay everything out on a table or in a shoebox, but I made a little wooden half box to organize the parts. The case is 3 pieces of scrap exotic hardwood in an H shape with rubber feet on the top and bottom. The Pi and other equipment hang underneath the top, so it can sit on my shelf, look nice, be protected from dust when right side up. Yet when I flip it over, there's easy access to the Pi and wiring. It's hardwood, so I can drill and tap 440 size machine screws for mounting. Underneath the Keyestudio Relay board, I have a Pi Juice battery system installed, so I have a completely wireless floating ground system. The power supply is from Amazon. It's a 12 volt to 3 amp USB microconverter with standard amateur radio Anderson power pole DC input plug. You can buy very small diameter screws that easily fit through the Anderson power pole roll pin hole, like Imperial thread 2x56. And then you add some nylon washers to space it off the board. There aren't many external connections. I connect my Raspberry Pi to the network using Wi-Fi, and I power it using a Pi Juice battery, so it can be used completely wirelessly. It takes a couple amps at 12 volts from external power to simultaneously power the Pi and charge the battery. The external Wi-Fi connection is nothing special. You'll need an internet access to download software, and you'll need to log into the Pi over the Wi-Fi using SSH. You can use a SSH program like PuTTY on Windows. The next step is setting up the operating system. During the OS installation stage, if my suggestions conflict with Raspberry Pi's official instructions, follow their official instructions. I'm just providing advice about what works for me. I use the Raspberry Pi OS Imager software to install the OS to a micro SD flash card. I installed the OS version released on October 30th, 2021, but in previous experiments, pretty much any recent version has worked. I'm doing a very simple headless server type installation known as the Raspberry Pi OS Lite Edition, and I preload the Wi Fi connection information by adding files to the boot partition. You need to add a file named WPA underscore supplicant dot conf file, and you need to add a file named SSH to allow remote SSH login on the first boot of the Pi. The WPA supplicant file contains all your Wi-Fi info. If you haven't done this procedure for a while, it's tradition to forget one step or the other, leading to some confusion, but eventually everything works. During your first login, you need to run sudo raspi config, and remember to double check SSH is permanently enabled, and in general, finish configuring the Pi. It only takes a couple minutes. You need to remember to set your locale, your time zone, and expand the file system to full size. You might want to change the password from its default Raspberry to something else. Try not to forget it. At this point in the process, your Pi has the latest Raspberry Pi OS Lite operating system installed. If, after rebooting the Pi, you can SSH log into the Pi over your Wi-Fi connection using either the username Pi and the default password Raspberry or whatever new password you selected, then you can move on to the next step. I also run an Ansible configuration script I wrote that modifies and installs software to help connect my Pi to my Active Directory domain, so I have single sign-on and access to my file servers. But all that really matters in the context of this project at this step is a working installed operating system that you can SSH log into so you can continue installing software. Now it's time to install the Node-RED based system. During the Node-RED installation stage, if my suggestions conflict with Node-RED's official instructions, just follow their instructions. I'm only providing advice about what worked for me. I use Node-RED's official installation script found at the link on this slide to install node.js, npm, the Node Package Manager, and Node-RED itself. I installed Node-RED version 2.1.3. You can verify that it'll auto start on boot using the command sudo system control enable node-red.service. The goal of this stage is to be able to log into the Node-RED system editor on port 1880. It's a web browser URL similar to http slash your IP address colon 1880. Pause the video until you've reached that stage. Finally, we install the Node-RED driver that connects Node-RED to the Keyestudio Relay shield. From the Node-RED menu, select Manage Palette, then the Install tab, then search for Keyestudio Relay Shield and then click on the Install button. Or you can run following commands from the command line. When you log in as the user Pi, you have to go into the Node-RED directory, which is a hidden directory. So that's .node-red. And then you use the npm package manager to install that specific name. Remember to restart Node-RED or reboot the entire system after installing a new node. Here's an example of installing the Node-RED driver software. Click on the hamburger menu in the upper right corner. Find Manage Palette. Click on the Install tab. In the search bar, type in Keyestudio. Select it. Click on the Install button. Should just work. Now I'm going to demonstrate how to install this using the command line. I'm currently logged into it. We'll change into the Node-RED directory. Now we'll run the npm command to install it. The install will take about 2 minutes. Then we'll restart Node-RED and it should just work. The node provides some example flows. In Node-RED, click the right side hamburger menu, select Import, Examples, node-red-contrib, etc. If you can run the demo example flow, then the install was successful. There's another completely separate video demonstrating how to use the software, the features, several different examples, ideas. This video is only about installing the software, but this will verify it worked. Here's a demonstration of the example. In the hamburger menu, scroll down to Import, select the Examples tab, expand the Keyestudio Relay Shield, select the Relay demo, click the red Import button, select it, Deploy it. Give it a try. All 4 relays are on. All 4 relays are off. Looks like it works. Please help Spring City Solutions fund the development of Node-RED-related software by donating on our project's Patreon page. You can find a link on the Spring City Solutions Node-RED project page, or you can scan the QR code seen here. Here's a review of the topics we covered in this video. We installed the hardware, installed the Pi operating system, we installed Node-RED, then we installed the Node-RED driver software for the Keyestudio Relay Shield. Along the way, we checked out the example flows, and I hope you donate to the project. If you need to contact us, this project has a dedicated email address at Spring City Solutions. It's nodered@springcitysolutions.com. Raspberry Pi is a trademark of Raspberry Pi Trade-In. Keyestudio is a registered trademark of Shenzhen Keys DIY Robot Company Limited. Node-RED is a registered trademark of the OpenJS Foundation in the United States. This was a Spring City Solutions production. Copyright 2021. Thanks for watching.